Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 19 should come up on your screen. By now, we should be experts at standard deviation. And let's see how you do with problem number 2. You can answer that on the screen in regards to what type of variable is being used in that situation. All right, I'll give you some time. Copy and go. So let's go through this really quick. Now, I do want to make sure that I think I've been giving you plenty of practice with standard deviation. By now, you should be experts. But here goes one more time because we're about to get into bigger and greater things with data, which means when we collect data that has more than 20 different numbers, imagine collecting data having 50 to 100 numbers. Yeah, so then, it starts getting funner by the minute. So let's go through the process one more time. What is the first thing we do with this data, everyone? Ascending order. So we start with 2, 5, 6, 8, and then we got 10 and 12. All right. What do we do with that then? Yeah, find the sum first. So I'm going to write my symbol. If you guys forgot how to write sum, it's that Greek letter sigma. So the total should be, let's see, 22, 36, 41, 43. So far so good, yes? Yes? Yeah. No, sigma is the sums. Yeah. But now we're going to find, divide by how many numbers? 6. So we're going to find what? The mean. Is that correct? All right. So 43 divided by 6. Yolani, what'd you get? 7.6. Hands, have you got that? 7.16. Okay, hands, have you got that? All right. So what do we do with that? Well, we take this and subtract it from those numbers. Yes? So I'm not going to show the step, but I'm just going to do that in my noodle. So this is negative 5.16, negative 2.16, and then we got negative 1.16. Then we got 0.84, 1.84, and 3.84. Hands, have you got that? All right. What do we do from there, everyone? We square each of those numbers. We get that over here. Yes? Is it 4? Yeah, I did that to see if you guys were paying attention. 4.84. All right. Pretty good, right? 2.84 this one? All right, thank you. All right, so we square each one of those. So what'd you get for this squared, Alec? 516 squared. 27.04. I'll go with that in estimation. How about 216, Eric, squared? 4.66. 1.6 squared, Albert? 1.16? Yeah. 1.35? 1.35? Yes? Approximately. 0.84 squared, Sean? 0.64. 2.84, Giselle? 2.84 squared. That's all right? 2.84 squared. 8.06. All right. And then we got 4.84 squared. What'd you get, Bree? 4.84 squared. 23 what? 33. Okay. And then what do we do with all those? Again, we find the sum and then divide by 6, and that should give us the new mean. And that new mean is known as the squared standard deviation. Yes? What'd you get for the squared standard deviation, please? Alex? 10.8. All right. And from there, we need to take the square root to get our standard deviation. What'd you get for standard deviation? Gabriel? 3.28. Hands up, you got something close to that? Yeah? All right. So, our bell curve, we got our mean, which is 7/16. First standard deviation at 328 plus 7/16, that's 10.44. And on the other end, on the negative side, it would be 7/16 minus 3.28. That gives us 3.88. Yep. Okay. And that's our normal range. So normal range is from 3.8 all the way to 10.44. Now, what does that mean? Look up. What was the situation? 7 students were asked how many hours of sleep they got on Sunday night. 2 hours, 12 hours, 8, 5, 10, and 6. What can you conclude from that data? Tell your neighbor, please, what can you conclude from that data according to the bell curve? What can you conclude? All right, write it on your paper, please. Write your conclusion on your paper. Yeah, some of y'all need to get some more sleep. That's what it concludes. Right? Yeah. Come on. On a Sunday, you guys should be going to bed early. Right, Alex? All right, number 2, classify the variable, either nominal, ordinal, interval, and ratio. Here's the situation. When selecting a valedictorian and salutatorian, schools look at all grades from elementary all the way to high school and compute the GPA for each candidate. And they look at the candidates and they rank them according to GPA. Now, since they go far back, their GPA is also, it goes to the hundreds, so they're really careful at that. Sometimes they need to go one more to the thousandth decimal. So, tell your neighbor what kind of variable that is, nominal, ordinal, interval, or ratio, and tell them why. Which one? All right. Good conversation, and I think Ethan has got this one. Aguirre. So, is it nominal, ordinal, interval, or ratio? And why? So let me help you out. Do they gather names? Yes. So that in any order, it would be nominal, right? Any order. But once they order them in a specific order, it's ordinal. But does each ranking count to select the valedictorian and the salutatorian? Yes. So therefore, that becomes what, Ethan? He said interval. Hands if you agree with interval. Yes, because each rank is specific and it's different from one to the other. Okay? So interval. All right, copy the agenda for today, please. Warm-up number 19, statistics and probability. Tonight's home play is only 7 problems, only. And once again, reminder, there is tutoring after school, just like last year. like every year, and it's free. So if you need extra support, come see me. If you don't, then no. Be nice. So once again, warm-up number 19, stats and probability. Tonight's home plate, 7 problems, data sampling methods. QR code, the Nearpod code, ALBQ4. Write that down, please. You can get your home plate. ALBQ4, ALBQ4. All right, and for the home plate, when you get to the problems, instead of writing out the situation and the question, just write me the answers for each number, okay? All right, there are the 7 problems. Make sure you get to those tonight. All right, here we go. I can identify data sampling methods. I can identify data sampling methods. You don't need a Frere model. We're still dealing with statistics, and we're still getting into some of the different statistics that we're using. And that's why, if you notice, I put data sampling in blue, because even though the main concept is statistics, data sampling is an umbrella. Under the umbrella of statistics, we're using data sampling. Huh, Alex? Goodness. All right. So, without further ado, we are going to be looking at different data samples. But by now, you should know what statistics are. Tell your neighbor the definition for statistics. All right, without looking at your notes, thank you very much. Appreciate it. On your screen, type in your definition, 30 seconds. Okay, 29 seconds. Definition on your screen. Ah. So the science of what? Collecting, surveying, summarizing, analyzing, and doing all kinds of stuff with data. But what do we do at the end? Tell your neighbor the key words at the end. What do we do at the end? Conclusions. We come up with conclusions with the data that we get. That's the most important part after we massage and get all that data together. Okay? All right, so here goes the next part. Writing utensils down, look up to the screen. So, when statisticians are asked to collect data, there's specific methods that they use. And I'm pretty sure you guys have been exposed, all of you, to some of those. Maybe you've been at a mall. Have you guys noticed some people with clipboards that they want to ask you questions? Okay, that's one method. Another method, have you gotten phone calls, weird phone calls, that they want to ask you questions on those phone calls? Some of you, yes? That's another way. How about emails? Have you gotten emails, weird emails, that they want to collect information? Well, guess what? Those are the most common type of surveys that they do. So here we go. Don't write this down. Pay attention. To collect data, there are certain surveys that are done. The most common are via mail or email questionnaires. The other one, like I mentioned, via phone, unknowing, because sometimes they're very persistent. And the last one would be personal interview. Why? Because they are at the mall and they're like, excuse me, do you have like 20 seconds? I just have some questions. You know what I'm saying? And all of a sudden they get you and it goes for 5 minutes. So 3 different types of surveys. That's how they collect data. Are there others? Yes. Check this out. If I was a statistician and they asked me that I needed to collect data of whatever the type, I can just go to the mall, sit right there at the food court, look at everybody using the different types of venues there, and I can collect data just by doing an observation. Is that correct? That's another type. There's different types, but what are the most common? Mail, telephone, and? All right. So, before I move on, once again, to collect information, there's surveys done. So tell your neighbor the most common ones. Tell your neighbor the most common ones, please. Most common ones. All right. Looks like we got it. Yes. All right. So most common surveys. Emilio. What's that? Phone calls. That's one. Another one. Priscilla. Email or mail via, with those papers that they fold and put in an envelope. Yes. And one third one, Alice. Personal interview, face to face. All right, we got those. Now, we've already mentioned in the past that when collecting data, it's expensive. It costs money and time to collect a bunch of data. Therefore, we simplify it and make it smaller, and we collect what? Samples, sampling. That's why it's smaller, and it's not as expensive and not as time-consuming. Here we go. There's 4 different types of sampling done. Copy this, please. Write it down on your paper. Data sampling methods, 4 of them. Leave 2 lines of space for each one of these. The first one, random sampling. The second one, systematic sampling. The third one, stratified sampling. And the fourth one, cluster sampling. Once again, leave a couple of lines for each of those so like that we can get a definition and at least an example. When collecting data samples, once again, the most common and the 4 most common are random sampling, systematic sampling, stratified sampling, and cluster sampling. Now, we're going to come up with definitions by me showing you how to do this survey. Okay, here you go. First thing I'm going to ask you to do, everybody got a index card, is that correct? All right, get that in front of you. All right, first thing I want you to do, you're going to write your name in the front where the lines are at, nice and big. First name, last initial, that's fine, or both names, is up to you. Big. All right, and in the back, I'm going to give you a number to write down. Make sure it's nice and big, like mine. Let's go. I'm going to give you a number. All right, here we go. Y'all ready? Here goes the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Write that in the back. Be nice. Be nice. All right. So check this out. I'm going to demonstrate each of these sampling methods with you guys. I'm a statistician. Ready? Then we're going to come up with definitions by you talking to your neighbor. So stay focused, pay attention. Bah. Here it goes. So the first way I'm going to collect data, here it goes. I'm going to use you guys. I'm going to ask you to get your index card. I'm going to ask you to get up. Black shirts on that side, all other colors to the right. Black to the left, all other colors to the right. Hurry up, hurry up, hurry up. All right. So we have black shirts on the left, all other colors to the right. But all of you are my data, right? All of you. But what did I just do first? Okay, that's that's step one. Step two, I'm going to ask that group over there, give me your index cards, all of you. And I'm going to use their data, the entire group. You can say over there really quick. Thank you. 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 So check this out. Cluster sampling, step one was to do what, Emilio? Into different groups. And then what did I do next? Did I use everyone? I used one of them, one of the groups, and I used what? The entire group. Are we there? All right, talk to your neighbor in your own words. What is cluster sampling? Because I'm going to sample from here. What is cluster sampling? We collect data and do what? Cluster sampling. Talk to your neighbors. All right. Let's see. Cluster sampling. Alex, what do you think cluster sampling is? Did we hear that? Here it goes again. He said, you collect data, separate into clusters, and you use all the data in one of the clusters. Does that make sense? That is correct. Here goes the second one, stratified. Again, if I was to give these back to them, right? Imagine I give these back. Here goes stratified. For stratified, I said, you know what? I'm going to use now this group. Give me your index cards, please. All of y'all. Yes. Hurry up, hurry up, hurry up. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. All right, here it goes. Pay attention. So, cluster sampling, we said that we get into different groups and use the data from one group completely. Stratified, this time I'm going to use this group over here, but I'm going to do this. Just these. Talk to your neighbor, let them know the definition for stratified sampling. Stratified sampling. All right, so we said cluster, we collect the data, segregate into clusters, and then from there use the entire data of one whole cluster. What is stratified? Alex, what do you think stratified is? A sample of a sample. So I'll take that. That makes sense. But once again, using proper words, we say we get different clusters from the data collected, use one of the clusters and do what? A sample of each, but do I do it by looking at it or what? Randomly, you select certain ones from that cluster. All right, have a seat. We can do the last two in a little bit. Thank your neighbors. Thank you. Appreciate it. All right, so let's start with cluster. Alex said collect data, comma, separate. Oh, my bad. Let me use Emilio's word. Segregate into different clusters, comma, and the key point at the end. What do we write at the end? What is key at the end for cluster? Select the entire cluster, right? Select entire cluster or data from cluster. Okay, so one of the clusters, select the entire cluster. Okay. Stratified. Stratified, we start again with collect data. Then we do what, everyone again? Segregate into different clusters, comma. So what does stratify, why is stratify different than cluster? Alex, what do you say? So then do from there randomly select samples from a cluster. Yes. So in this case, we don't use the entire cluster. We only select certain ones from the same cluster. Does that make sense? Yes, so far? Yeah? All right. Now, check this out. Let me illustrate systematic. Ready? Look up. Do I have all your index cards? Okay. Have I segregated them? No, I mixed them up, right? Now check this out. Here goes systematic. Ready? 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. And these go in the pile over here. So I'm only going to use these. Talk it over to your neighbor. Let them know, what did I just do? What did I just do? All right. So, again, let's write collect data. I collected the data, right? I got your index cards. Did I segregate this time? I separated into groups? No. What did I do in order to get my data that I'm going to use? I used a system, to randomly select the sample. It's random because I mixed the cards up, right? Since I mixed the cards up, it's random. But now I have a system to randomly select. It's still random, right? Because I mixed them up, but now I have a system. Could I use a different system? I used every 6. Could I mix it up? Yeah. 1, 2, 3. 1, 2, 3. 1, 2, 3, and so on and so forth. So select a system on how to collect the data. Okay? All right, last but not least, here we go. I collect all the data, and then just do this. Whoop. Whoop. I'll get this. This one, this one, this one, this one, and that's it. Tell your neighbor what random sampling is. What is random sampling? All right, looks like Jeremy's got it. We collect data. Of course, we start by collecting data. And then what? Choose data at random. Pretty much. Yep, that is correct. All right. From 1 to 5, I'll come to you with the 4 different sampling methods. 5 fours, 5 fours. Okay, okay. All right. Now, let's see how we do. Ready? Here we go. Look up. Here's the state of California. Ready? And we segregated into counties. Different counties. You guys see the different counties? And I want to do a survey as to what kind of chips people eat. And I'm going to select Imperial County. Okay? Ready? Are we there so far? So first of all, state, county. Check this out. So now, within the county, I want to know who likes Flaming Hot Cheetos or who likes Takis. Are we there? I collect the data. However, I'm only going to use randomly some numbers from the Takis. Tell your neighbor what kind of sampling that is. State, county, Flaming Hot Cheetos, Takis, and then randomly select only some from one of the groups. All right, Georgia, what do you think? Stratified, why? So we segregated, and then I only use what? A random sample from the group. Yes, I didn't use the entire group, right? All right, look up to the screen. Here goes another example. Out of 16 school districts in Imperial Valley, one was selected to collect records for one school day on the number of referrals issued for the day. Don't say it out loud yet. Think about it. There are 16 districts. We select one of them and collect all the data for referrals. Tell your neighbor what kind of sampling that is. All right, looks like Serena's got this. Serena, go. Cluster, hands if you agree with cluster. That is correct. Let's go. Here goes another one. Mr. Shaw divides a group of students that are making line. There's 2 lines. By height, 1 line. The other one by GPA. Then selects a handful from each group. A handful from each group. Tell your neighbor what kind of sampling that would fall under. What kind of sampling that would fall under. I know it got a little confusing because he's using both groups, but did he use the entire group from each? No, so he stratified. He stratified, all right? Here goes another one. El Centro Costco, every 10th family-sized Dorito bag is selected to measure if the content net weight is accurate. The purpose is to see if the Dorito packaging machine is working properly. Tell your neighbor what kind of sampling that is. All right, Bernard, what kind of sampling is that? Hands if you agree with systematic. That is correct because there's a system to randomly select. Look at this one. Mr. Q concealed the names of students and used numbers with index cards. Then use the index cards to randomly select a small group to answer questions. So you know what kind of sampling that is. Leah, what kind of sampling is that? Random, that is correct. Even the word is in there. Randomly selects. All right. So, from 1 to 5, how comfortable are you with random sampling? All right. So, I'm going to ask you on your own later on. You can fill in an example for each so that you get it to make sure it's yours. However, look up. Let's see if they remember. Tell your neighbor, what are the 3 most common types of surveys? 3 most common. All right? So, on paper, write it down. The 3 most common type of surveys are, write them out, all 3 of them. Get us started with one. Drew, what's one type of survey? Mail questionnaire. You can also, in parentheses, write email. That's fine. Noel, another one. Telephone is the second one. All right. And one third one, Albert. Text, it's still kind of like mail. How about personal interview? Personal interview. Make sure it's in there, so that when they stop you at the mall and they're like, "Can I ask you a question?" and you're gonna ask them, "Are you doing a survey?" Bam, let's go. Anyway, we'll stop right there. Once again, make sure you have the code for tonight's home play. The home play is on the screen. Make sure you get that done. Just answer the questions, and we'll stop right there. Good home play. See you guys tomorrow. Bye. You too. Oh, thank you.